Welcome to Data Science with EJD. Of course, data science is that broad field that involves things like machine learning and all that. So, uh, for the most part, we've been talking a lot about machine learning, which tells us about the idea of devices, machines, and all that, learning from data. And we see that machine learning is subdivided into supervised learning, unsupervised learning, and reinforcement learning. Talking about supervised learning, it is machine learning from labeled data. And when we talk about labeled data, we have data such that we have inputs and outputs. The inputs are the features that determine the outputs called the targets, right? And then we have the unsupervised learning, which involves unlabeled data. So here we just have only the features, and all we are doing is to discover patterns, associations, and things like that from them. And lastly, we have reinforcement learning, where as the learning process goes on, a favorable outcome leads to more of that behavior, and an unfavorable outcome leads to the discouragement of the behavior. So, and for supervised learning, right, we've gone through that where we saw the two main algorithms, which are classification and regression algorithms. For supervised learning, where this is currently where we are on, we've looked at two sets of algorithms, clustering algorithms, followed by dimensionality reduction algorithms. And currently, we are looking at association rule learning algorithms, where we have seen a priori algorithm, market basket analysis, which depends on a priori algorithm also. And this is the third video on association rule learning. I guess it will be the last or so. It all depends. If something else comes up, I might just still talk about it. So, here we're talking about FP growth algorithm. FP growth algorithm. By the way, FP means frequent pattern growth algorithm. Okay. So what is the FP growth algorithm again? Frequent pattern growth, FP growth is an efficient and scalable method for mining the complete set of frequent item sets without candidate generation. So you see, in a priori algorithm and market basket analysis, we have to go through item by item. We have to go through all the different item sets. But frequent pattern growth algorithm can go straight to the point without having to generate those sub item sets, right? So it was proposed as an improvement over a priori, addressing its inefficiency when the data set is large and dense. So when we have large and dense data sets, a priori algorithm and market, upon which market basket analysis is dependent, is going to fail. So the best method we want to use in that case is the frequent pattern growth algorithm. And the objective of this is this: given a transactional data set, you want to find all item sets whose frequencies or support occurrence frequency is about support, right, exceeds a predefined minimum threshold. So we set the threshold and we just get the result, right? So for example, in market basket analysis, you want to find items frequently bought together and you want to use it to create recommendations or marketing strategies. So the next thing is how frequent pattern growth works step by step. First of all, you scan the database. So count the frequency or support of each item, discard items below minimum support, sort remaining items in descending order of frequency. Then step two, you construct the frequent pattern tree where you initialize the roots as a null node. You initialize the roots as a null node. Then for each transaction, you filter out infrequent items. Then you sort by descending frequency, insert items as a pattern into the tree. If a prefix exists, increment its count. If not, create new nodes. The FP tree is a compact representation that compresses common item prefixes. So you just focus on the common items and not worry about the item sets. Then in step three, you mine the frequent pattern tree. So for each item, starting from the least frequent, extract its conditional pattern base, subsets of transactions containing that item. So you can construct a conditional frequent pattern tree and recursively mine this smaller tree. So this divide and conquer approach finds frequent patterns without generating a huge candidate set. So the problem with a priori algorithm is that you're going to have several item sets and then before you get the real thing you want. But here you can go straight to the point and just focus on the key item. So that's why it's called frequent pattern growth. So why frequent pattern growth is more efficient than a priori? Of course, talking about candidate generation, that's the major problem, right? So in a priori, it generates all possible candidate item sets, but FP growth avoids candidate generation. Then database scans. From a priori, many scans because you need one per iteration. Then FP growth, you have only two scans where you just build tree and then mine the tree. Then you have the memory usage. You have high memory usage for many candidates in a priori, and for frequent pattern growth, you have which it's more compact with shared prefixes. Then you have performance on dense data. Poor a priori is poor on dense data, while FP growth is excellent on dense data. Okay, so the key advantage now, frequency pattern growth exploits the structure of the data set by compressing it and mining smaller trees rather than scanning repeatedly, right? So that's the key advantage. It exploits the structure of the data set by compressing it and mining smaller trees rather than scanning repeatedly like you have in a priori algorithm. So example data set now. I mean, the same one we've done before. So let's use a simple toy data set. Oh, not the same one, but something close. Let's use a simple toy data set of supermarket transactions. So transaction one has milk, bread, nuts, apple. Transaction two, milk, bread, nuts. Transaction three, milk, bread. Transaction four, bread and nuts. Transaction five, milk, bread, apple. So you see the minimum, if you have a minimum support of 60%, that means item sets are appearing at least 3 out of 5 transactions will have that minimum support. So these are 5 transactions, right? So you see milk appearing in more than 4 places, in more than in 4 places out of 5. That's 80%. Bread is appearing in 100% of the case. So bread is like regular. Then nuts is appearing 3 times. So and then apple. So apple is not as common as bread, milk, and nuts, right? So we already have that going. So let's do Python implementation using ML extend. So of course you want to install the required library. We've done that in previous situations. But if this is the first video you're seeing, you may just want to run it if you've not run this before. So ML extend for this. So, and then you have this. All right. I already have it installed. In your case, it may take a bit longer if you have not done it before. So encode the data set now. So we want to encode the data set because we need a transaction encoder because of, we're talking about transactions, large transactions here. So import pandas as speed because we want to make a data frame, of the encoded transactions. So you have data set, milk, bread, all the things we had up there. Then encode it as one hot data frame. So you have T as transaction encoder, TR is T feed.dataset.transform dataset. It's like the standard thing we've been doing all along. Then you have the data frame that's PD data frame, T array columns, like that. And then it gives us the items available in each transaction. Okay. Oh, okay. So that's happening again. Okay, I'm here now. Okay, so you see, in each transaction, it tells you which one is there or not. So apple, bread, milk, nuts, these are the 4 things. So in the first transaction, we had apple, bread, and milk. In fact, we had all the 4. In the second transaction, there was no apple. In the third transaction, there was no apple. There were no apple and nuts and things like that. Then you can now apply the frequent pattern growth algorithm. So from ML extend dot frequent underscore patterns, you import FP growth. So find frequent item sets with minimum support of 0.6. So you set the 0.6 support directly, and then just go for the only things that match with that appear at least 60% of the times. Right, that's 3 out of 5 times. Then you just get that directly, so you don't have to generate all the plenty things. So bread is almost always bought. Then 0.8 for milk, 0.6 for nuts, 0.8 for bread and milk combination, 0.6 for bread and nuts combination. So I mean, you go straight to the point without having to generate every item. Then you can derive association rules now. So of course, I put the second 2 lines to, there's a warning attached to it, maybe because of non-available values or something like that. So this is to just suppress the warning. We ignore the warning, right? So, but the actual thing is we want association rules. So generate association rules with minimum confidence of 0.7. So we go with this association rules, frequent item set, metric is confidence less than at a minimum of 0.7. Then you can check if there are any not available values in the rules, which is optional, and then you can print selected columns from the generated rule. So you have this. So nothing is missing because they all have 0. So antecedent 0, consequence 0, antecedent support, consequence support. Everything is 0. So nothing is missing, right? Then for the association rules now, most of the times bread first, followed by milk, and that will happen 80% of the times. The support is 8%, 80%, the confidence is 80%, the lift is 100%, right? Milk and bread, nuts and bread. So the lift is 100% that guarantee that it will always happen. But if you want to look at the strongest, to be milk and bread, right? Because you have 0.8% support, confidence is zero. Oh no, it can't be milk and bread to be milk. Oh, okay. Well, it is milk and bread, not bread and milk. Milk and bread. That's milk first, bread second, right? So if you buy milk first, most likely you're going to buy bread, and then I mean it is guaranteed you buy bread once you buy milk. Okay, so and that goes on like that. So the expected results now you have, all of these things. I mean, we've seen the results already, so we don't have to belabor the point. Okay, so advantages of frequent pattern growth algorithm. So first of all, no candidate generation because it's faster than that's why it's faster than a priori. Then only two scans of the database, right? Then it handles large and dense data sets well. It is easy to implement with libraries like ML Extend. Then the use cases we have it. We need it for we can use it for market basket analysis. The other time we used a priori algorithm for basket analysis. We can also use frequent pattern growth algorithm for market basket and I call it like market basket analysis. Then you can use it for recommender systems like recommending video movies or whatever, web log mining, bioinformatics like frequent subsequences, intrusion detection, frequent attack patterns. You want to see all that. So if you're a detective or a cybersecurity person, this can be useful for you if you have some information. So now, how do we visualize the FP tree structure? I mean, I've said it a couple of times. Step by step, we can use the toy data set like milk, bread, nuts, and apple that we've been talking about. So the first thing you want to do is calculate the item frequency. That's the support counts. So in how many of the transactions does bread appear? Bread appears five of the times. Milk is four times. Nuts appears three times, and apple twice. So the next thing you want to do is, assuming minimum support is two, all items will qualify. So if minimum support is two, all the items will qualify. Then the next thing you want to do is other items that are descending frequency. So bread is five, milk is four, nut is three, apple is two. Great. So we have that done. So the next thing is you now want to reorder each transactions item according to frequency order, right? So you have bread, milk, not apple, bread, milk. Okay, I mean we have the regular thing there. Then step four now, you can build the frequency pattern tree now. You start with an empty root node labeled null. So you have null, and then next is bread, milk, not an apple. So root is null, right? Followed by bread, which is so bread is count one. Then again, bread to milk is count one. Milk to nuts is count one. Nut to apple is count one. Then it starts the next tree now. You have bread, milk, nuts. So here, bread already exists under roots. After root, the next thing is bread. So bread already exists after root. So you increment count to two. Then milk already is already child of bread. After milk, after bread is milk, right? So it means milk is child of bread. So milk is already child of bread. Increments count to two. Not already child of milk. Increments count to two. So then insert transaction three, you have bread and milk now. So bread is now count three. Milk is count three also. Insert bread and nuts. So bread is now count four. Nuts is bread child. No, is not bread child. No. So no. So you create new node nuts with count one under bread. So you have bread, milk, apple. So bread count is now five. Milk is count four. Apple is milk child node, so create apple node count, which is one under milk. So generally, all you have is you start with null, then bread goes five times, followed by milk. So milk is child of bread, so it goes straight. Then next, nut is child of milk, so it goes straight again, and nut appears twice. Then apple is child of nut directly. Apple is also child of milk separately. Then nut is child of bread directly like this also. So that's how that is. So the Python code for this, you do what is it called now? Object-oriented programming in Python. So you create classes and functions, class FP node, and you do all of this whole thing. So you have self item counts one, blah blah blah. So it is just the Python way of doing the same thing we've done up there. So if you want to look at this properly when you're settled. So we have the same result, just like okay, I think we've gone past this, right? Okay, okay, I was still running that code there. Okay, I think I know what the issue is. Yeah. Okay, so I run this now. So and it gives So it just gives null is 0, bread is 4. So from null to bread. So anywhere there direct connection, that's what you have going like this. So bread to milk directly, milk to not directly, not to apple directly, but and then milk to apple directly, and then bread to nuts directly. And that's exactly what this tree shows us. Okay. So in summary, uh, the type, so a priori is breadth first, generate and test. Breadth, if you remember, okay, well, I don't. If you have seen my videos on network, graph and network theory, so there's a place where we talk about how to travel along a network, so we can have breadth first or depth first, right? So a priori is breadth first, then generate and test, while fast path growth is depth first. So depth first is you go down the street and then you come back step by step. Then breadth first is you visit each place one after the other. So if you want more information on that, you can check my playlist. It's a whole playlist of maybe at least 15 videos or so. I'm not sure about. So it's about so there you can find that breadth first and depth first approach to traveling along networks. Okay, so there's a pattern growth there. So efficiency, a priori is slow for larger dense data set. FP growth is much faster. Candidate sets, a priori, yes. A priori, yes. FP growth, no, because it just goes straight to the point. Then memory, a priori requires large candidate tables, and FP growth just needs compact tree. So the final takeaway is that FP growth is the go-to algorithm for mining frequent item sets efficiently, and it's the basis for many practical recommendation engines. So if you want to be the recommender system, so frequent path growth, of course, will be it for you, right? So with this, we come to the end of this video. Let me know how helpful this video is for you. And if there's something you'd like me to do, you'd like me to try out, feel free to let me know. If you have subscribed already, thank you so much for that. If you have not subscribed, please go ahead and do that and hit the notification bell so you can always get alerted each time a new video is released. So on my channel, you can become a member with some special privileges. So just click on join and see the possible membership levels there for you. Um, uh, Again, my code sheets are available, so you just check the description box and click on it. You can get all the code sheets, and then follow along. I prefer that before you even start watching the video, you download the code sheet and follow step by step. Uh, Tweak things. You can copy out a code and change some values and see what happens, so you can learn as things go on. All right, so be sure to like and share this video and other videos also, so that you can always get alerted each time a new video, so that more people can have access to this great content I have going on here. Till I come your way again, keep doing data right. Bye.